The rule of least power. Kind of sounds like something from Lord of the Rings, doesn't it?
Cast it into the fire!
No. Well, it's not something from Lord of the Rings. Programmers are just nerds. It's actually a software principle that has huge implications on the maintainability of the code you write, even if you've never heard of it before. Now, the first time I heard about the rule of least power was when I heard Tom Dale and Yehuda Katz talking about Handlebars, which is the templating language that Yehuda created. Now, you've probably used Handlebars or Vue templates or some other templating language, and if you have, the first thing you'll notice about these languages is that they look an awful lot like HTML, and that's no accident. See, HTML is not a programming language, and that was a deliberate choice by Tim Berners-Lee, the creator of the World Wide Web. He says, "I chose HTML not to be a programming language because I wanted different programs to do different things with it, present it differently, extract tables of contents, index it, and so on." Now, if you think about the web, this actually makes a lot of sense. When we visit websites on our phones and computers, we do a lot more than just read them, right? We can share them with other people, and those links can have rich previews. We can use our iPhone's reader mode to just get the content of a page without all the other junk. We can use browser extensions to interact with our websites. And perhaps most importantly, companies like Google can actually scan and index all the content of all these different web pages and compare them to give us the best match for whatever term we're searching for. And all this wouldn't be possible if HTML were a true programming language, because arbitrary programs written in Turing-complete programming languages just can't be analyzed or compared. They're just too complex. So when creating the web, Tim deliberately restricted the power of HTML in order to make all this other stuff that we do with websites and web apps possible. Here's Tim again. Computer science in the 1960s to 80s spent a lot of effort making languages which were as powerful as possible. Nowadays, we have to appreciate the reasons for picking not the most powerful solution, but the least powerful. The less powerful the language, the more you can do with the data stored in that language. So that's the essence of the rule of least power, that the less powerful a language is, the more you can do with programs that are written in that language. And this is what Tom and Yehuda were talking about at EmberConf. They were explaining that because a lot of the code in Ember apps is written in Handlebars templates, that gives them as the framework authors more flexibility to do things like statically analyze those templates to improve performance. And Evan You, the creator of Vue.js, has made exactly the same point about Vue templates. He says, templates versus JSX is a bit like ES modules versus CommonJS, giving up a bit of dynamic flexibility in order for easier static analysis that leads to all kinds of optimization opportunities. Now, if you saw my other video on ES modules, you'll know that ES modules are static, and they don't let you do the kind of dynamic requires that CommonJS modules let you do. But this constraint is exactly what lets the browser pre-compute the dependency graph of your ES6 modules without even having to run your app code. So again, we see the rule of least power at work. When we opt for modules that are static and less powerful, we get this benefit of being able to pre-compute the dependency graph. Now, the interesting thing about Evan's quote is that Vue actually supports both JSX and templates. So the question is, why is that? Why did Evan decide to include JSX if the rule of least power tells us about the benefits that come from deliberately underpowered templates? He answers that question in this tweet, where he says that JSX and the virtual DOM give developers the ability to construct, reflect, and operate on the desired render output with the full power of JavaScript, and that this ability is important for library authors and tools/system building on top of the technology, which explains why the React ecosystem is so rich. So you can see that there's a trade-off here. Less powerful languages and technologies can provide benefits, but they're also just less powerful. You can't do as much with them as you can with more powerful technologies. And sometimes, depending on your situation, more power is exactly what you need. Tim Berners-Lee actually makes the same point in his article, and I like his phrasing. He says that in aiming for simplicity, one must of course go far enough, but not too far. the language you choose must be powerful enough to successfully solve your problem, and indeed, complexity and lack of clarity can easily result from clumsy efforts to patch around use of a language that is too limited. So, less power can yield benefits, but you have to be careful not to drop that power too much. Now, when Tim defined this rule of least power, he was talking about HTML, but hopefully you can see that it applies to way more areas in programming than just that. And that's because at the heart of the rule of least power is really just this principle of good design, which is that we should boil down whatever solution we're working on to the smallest possible version of it that still achieves the particular goal we're trying to achieve. For instance, in object-oriented programming, it's a best practice to restrict the public interface of your classes, to keep the public API small. Doing so gives you more freedom to change the private methods and other implementation details of your classes later on. Webpack is another example. A Webpack config is a pretty high-powered device, but it's also practically impossible to analyze. And that's why tools like Create React App are so restrictive in what they allow you to customize, because doing so unlocks a huge benefit. You can update your Create React app just by bumping the version of a single dependency. And finally, what about UI components? What does the rule of least power have to say about them? Well, maybe you've heard of something called the apocalypse. It looks a little something like this. We've got this user form. It takes in a first name, a last name, an address, a city, a state, and so on. This is the apocalypse, and it's an explosion of props or arguments to our components. Now, these things tend to be insidious and happen slowly over time, but it's worth looking at a component like this and asking the question, have we made our component too powerful? One way I like to answer this question is to think of my components as function calls. So this user form component could really be thought of as a render user form function. And that's really what components are, function invocations. So if this component were a function, what would this function's signature be? It would take in a first name, and then a last name, and then an address, and then a city, and so on. And we can see this argument list is getting pretty long. So if you were writing normal code and you were writing a function like this, do you think you would let the argument list get this long? Well, probably not, and not for a few reasons. First, it's kind of hard to use. It's just hard to remember the order of all these arguments. But second, and I think more importantly, is that by separating the arguments like this, you've made it possible to call render user form with the first name from one user and the last name from another user. And that's not probably how you intended this component to ever be used. So if we were just in normal code, we'd probably write a function that looked more like this. Render user form, and it takes in a single user. And of course, the component version of this is to make a user form component that takes in a single prop, a user. And that seems much more reasonable, but it's also less powerful. We can't render our user form component in as many configurations as we could before. But this restriction is actually a good thing for this particular use case. We've deliberately restricted the interface of this component, and that's improved its understandability and usage. So again, we see that the rule of least power has something to say even about these modern UI component frameworks. I'll leave you with one last quote from Tim's article, which is really just a restatement of this rule. There is an important trade-off between the computational power of a language and the ability to determine what a program in that language is doing. So go forth and wield your power responsibly.
All you have to decide is what to do with the
Power
that is given to you.
Thanks for watching, and I'll see you in the next one.